Okay, we're looking at how do we solve one and two-step equations in one variable. All right, so to make a zero pair, we're going to do those in class. Okay, so some of the definitions we have for one and two-step equations is, let me readjust my screen. Inverse operations. So inverse operations are the operations but backwards. So it's like undoing operations. So when I think of inverse, I think of undo. So when we solve an equation, we start with our order of operations. So parentheses, exponents, multiply and divide from left and right, and add and subtract from left and right. To undo operations, we're going to work from the bottom up. So the last operation we did was add and subtract. So those are the first operations we're going to undo. Okay. Then the next step is multiply and divide. The next step is exponents. And the last step is our grouping or parentheses. Okay. So we're going to locate the variable in one equation, and then so we know which side to remove the values from. Okay, we're going to use inverse operations to undo our addition, making zero pairs, and then we're going to use inverse or multiplicative inverses or reciprocals to cancel out any multipliers. Okay. We'll show our work, of course, and then we're going to check our work using substitution. So that's just a way to verify that we have the right answer. Okay, another thing we have here is there are different types of solutions you can get from solving an equation. One is if you get something in the end like x equals 3, then you have one solution. That's it. The value that we're solving for is 3. Okay. If I get something like this, x plus 1 is equal to x. So if I have, let's pretend x is equal to 10. 10 plus 1 is equal to 10. Is that ever going to be true? No, not if I add 1 to it. So this is a no solution. There's nothing I can plug in for x that makes it true. Okay. Our last situation would be if I get something like x equals x. So like 5 is equal to 5. Or what if x was 10? 10 is equal to 10. Or pi. Pi is equal to pi. Look, these are all that's true, that's true, that's true. So I can plug in any value for x and it will make that equation true. Okay, so we get one solution, no solutions, or infinitely many solutions. All right, the situation. A prospector, that's a gold digger, accumulated some gold and brought it to the government office for weighing. The office has a pan balance, which is like this, and a collection of lead blocks that we use for weights. Those. The official put the scale on one side, the gold on one side of the scale, and the lead weights on the other side of the scale until the scale is balanced. So this picture here shows 3 mystery bags. So 1, 2, 3, and then a total of 12 gold weights on the right-hand side. So when they put the 12 gold weights, we balance out the mystery bags. So it's the same weight as the mystery bags, basically. So let's write an equation for this. On the left side of the scale, I have 3m, so 3 mystery bags, they're all weighed the same, is equal to a total of 12 weights, or 12 pounds. So how do I know how much each bag is worth? I'm just going to divide the total weight by 3, giving me 4 pounds in each bag. Okay, so we're solving for the weight of each bag. So what we're going to do today is to draw the scales, write the equation, and solve for the equation. All right, so this example. There are 3 mystery bags on one side of the balance and 51 ounces of lead in the other. So I went ahead and drew the picture. My picture is not as good as the one above, but that's okay. So I have 1, 2, 3 mystery bags, 3 question marks, equaling to 51. So I can do, my equation would be 3M is equal to 51. I'm going to say M is equal to a mystery bag, one mystery bag, the weight of one mystery bag. So I'm going to do, since 3 is multiplied by M, I'm going to use the inverse operation, which is to divide. And I'm going to cancel that out. I get 51 divided by 3 is 17. So each mystery bag is equal to 17 pounds. Okay, how could I check my work? I'm going to do a little check here. I'm going to start with my 3M is equal to, I should have left more room, sorry, 51. And we're going to substitute 17 in for 3, or for M. So I do 3 times 17 is equal to 51. I get 51 is equal to 51. Check if the left side and the right side of the equation keep balance, then I know that I substituted in the right value for M. Okay, you try this one. You try. All right, so what I got is one mystery bag and 42 ounces of weights on one side and 100 ounces on the other. Again, try. So I have my bag. I'm going to put one mystery bag and 42 ounces. And then the other side, I have 100 ounces of gold. So I'm going to do M plus 42 on the left is equal to 100 on the right. So I'm going to keep balance here. And the 42 is being added to M, so to undo it, I'm going to subtract 42 from both sides. So I get M is equal to 100 minus 42 is 58. Now we're going to check. I think this is my answer, but I'm going to verify. So M plus 42 is equal to 100. So I'm going to take my 50. Whoa, we don't want to do derivatives. Oh, thank you. Thank you, iPad. Go over there. Okay, so I have 58 from here. 58 plus 42 is equal to 100. I see I get 100 is equal to 100. 48 plus 52 is 100. So that verifies. My answer is the weight in the bag was 58 pounds. Okay, next up. 8 mystery bags and 10 ounces of weights on one side and 90 ounces on the other. So I'm going to do 8 bags. 2, 3, 4, 5, 6, 7, 8. Okay. Plus 10 ounces on one side. Plus 10 ounces. And then on the other side is 90 ounces. So I'm going to set this up. I have 8 mystery bags plus 10 ounces of gold is equal to 90. Okay. I'm going to subtract. So lowest order of operations first. I see I have the 8 and the 10 on the side with the left-hand side with the variable. The 10 is being added to the 8M, and the 8 is being multiplied. So I need to start with the addition and subtraction to undo first. Remember, we're following backwards PEMDAS, which is like SADMET. So addition and subtraction undoing first. So I'm going to subtract 10 from both sides, leaving me with 8M is equal to 90 minus 10 is 80. Now I'm going to divide both sides by 8. So 8 divided by 8 is 1, so I get 1M is equal to 10. Okay, let's check our work. So 8M plus 10, I just start by rewriting my equation, and then I substitute in my answer in for M. Okay, so 8 times 10 is 80, plus 10 is equal to 90. So 90 is equal to 90. Look, that checks out. So that is my answer. M is equal to 10. All right, last one you try. I got 15 bags on one side and 7 ounces of weight on both sides. There are 15 ounces. Yep, so 15 and 7. Okay, so I have, oops, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, plus 7 ounces. And over here I have 7 ounces. So I'm going to set this up as 15m plus 7 is equal to 7. Let's go ahead and balance this out. So the 15 is multiplying by m, and the 7 is adding to m. Which one do I undo first? I undo the adding. So I'm going to subtract 7. I get 15m is equal to 0. Oh, what? There's 0 pounds left? So when I divide by 15, how much is in each bag? 0 pounds. All right, let's check. 15m plus 7 is equal to 7. So 15 times 0 plus 7 is equal to 7. I get 15 times 0 is 0, so I get 7 is equal to 7. It's just the weights that I added to both sides that made that thing balance, because there was nothing in those bags. Okay? All right, so we're just going to straight solve some of these equations. Remember, the left side we're thinking as the left side of the scale, and the right side is the right side of the scale. So this negative 16 is being added to the m, so we need to add 16 to both sides. Okay, so m is equal to 59. Let's check. So m minus 16 is equal to 43. So I get 59 minus 16 is equal to 43. And 43 is equal to 43. We verified. If you get something like 42 is equal to 43, then we know that our answer is incorrect. Okay, so that's why we verify to double check that our answer is correct. Okay. Okay, you try. What is the 12 doing to the y? It's multiplying. So its inverse operation would be to divide. Our goal is to make a 1y. So 12 divided by 12 is 1. So I get y is equal to, 12 goes into 60, negative 5 times. Okay, so I'm going to check. 12 times negative 5, or 12y is equal to negative 60. So 12 times negative 5 is negative 60 is equal to negative 60. Verified. Love it. Okay. 27 plus 9x is equal to 90. What do we do first? Do we divide or subtract first? We're going to subtract because it's lower on the order of operations. So negative 27 on both sides. 9x is equal to 63. Then, now that I have my 9 mystery bags and 63 weights, I'm going to divide by 9 to see how much is in each mystery bag. And I get 7 pounds in each mystery bag. Okay, so I have 27 plus 9 times 7. So 27 plus 9x is equal to 90. Okay, 9 times 7 is 63. And then I bring down the 27, add those together. I get 90 is equal to 90, verified. So this is my solution. X is equal to 7. All right, next, you try this one. Pause the video and really try. Okay, remember, you get feedback by trying the problem and then verifying it with our work. That's how we learn. Okay, so I'm going to, looks like I have the negative 6 that's multiplied by the x and the plus 1 that's being added to the x. So I'm going to start by subtracting 1 because adding is, I need to undo addition and subtraction first. Okay, so I get negative 6 is equal to negative 17. Then, negative 6x, excuse me. Then I divide by negative 6, and I get x is equal to, negative divided by negative is a positive, so 17 over 6. Nothing divides out of 17 and 6. I'm going to take my calculator and divide 17 divided by 6, and this is about equal to 2.833. So that rounds the 3 to a 3. So about equal to 2.83. That's it. Okay, I'm going to ask for 2 decimals on the homework, so make sure you know how to round to 2 decimals. Okay, last few here. So negative 5 plus x over 2 is equal to negative 3. I'll do this one with you. What do we do first? The 2 is dividing the x, and the negative 5 is subtracting from the x. So we're going to add 5 first because it's lower on order of operations. So 5 minus 5 is 0. I'm going to bring down the x over 2, giving me negative 3 plus 5 is 2. And then how do I undo a divide? I multiply both sides. So I'm going to multiply by 2. 2 divided by 2 is 1. So I get 1x is equal to 4. We better check our work on this one. So negative 5 plus x over 2 is equal to negative 3. Then I'm going to substitute in the 4 in for x. So 4 divided by 2 is 2, plus negative 5 is equal to negative 3. And negative 5 plus 2 is negative 3 is equal to negative 3. So we know that our work is verified. Okay, you try the next one. 0 is equal to 6 minus y over 2. What is the 2 doing to the y? It's dividing. What is the 6 doing to the negative y? It is adding to it. So what do we undo first? The adding. So we're going to subtract 6 from both sides, leaving us with negative 6 is equal to negative y over 2. Since I have a negative and a negative, I'm going to multiply. Actually, how do I undo the 2? I'm going to multiply by 2 on both sides. So I get negative 12 is equal to negative y. And then how do I undo the negative here? Because I want a positive y, I'm going to multiply both sides by negative 1. A negative times a negative gives me a positive, and a negative times a negative gives me a positive. So y is equal to 12. Let's double check. 0 is equal to 6 minus y over 2. So I get 0 is equal to 6 minus 12 over 2. Division first. So 12 minus over 2 is negative 6. So I get 6 minus 6 is 0, and 0 is equal to 0. Looks like we have the right answer with y is equal to 12. All right, what about 7 plus 1 is equal to 7x? Well, I can see right away that this value and this value are the same. So if I add 1 to one side, is there ever any number I could plug in for x that is going to make this true? Okay. One of the ways we can verify is to subtract 7x. This is to give me 1 is equal to 0x. Is this true? Does 1 equal 0? Okay, so when the variables cancel, so I don't have any x's, and the statement is false, so 1 does not equal 0, what we get then there are no solutions. So there's no value of x that is going to make this true. So we say no solution. Okay, try this one. 5x plus 4 is equal to 5x plus 4. All right, notice we have the exact same thing on the left and the right. So no matter what I plug in for x, as long as it's the same number, which it is, so if I do 5 times 1 plus 4 is equal to 5 plus 1 plus 4, are those equal? Yes. How about if we did, here's another example. 5 times 10 plus 4 is equal to 5 times 10 plus 4. Are those equal? Okay, so this is infinitely many solutions. It means that any value of x, and I can plug in any value for x. All right, so here's how I solve this for real. Okay, I'm going to subtract 5x from both sides. So I get 0x, and 0x. I get 4 is equal to 4. So when the variables cancel and the statement is true, so 4 does equal 4, we get infinitely many solutions. Yay! Okay, so we say infinitely many solutions. All right, guys, go ahead and start your independent practice. And then when you're feeling confident, you're ready to take your mastery quiz. Okay? Okay.